Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, amazing people all over the world of crypto and blockchain. And today I have another amazing guest. And by his background, he's on a tropical paradise somewhere. He is the head of research at Autonomys. His name is Chen Feng. Chen, welcome to the show.
Yeah, thanks a lot, Jamal, and thanks for having me. It's such a pleasure to chat with you.
Awesome. Thanks for joining me. And I look forward to this conversation. So let's kick things off. And I'll ask you first, before you arrived on Tropical Paradise, what is your background and is it a logical background for what you're doing now?
Excellent question. I will give you two answers, a short answer and a long answer. Okay, the short answer is I'm currently associate professor at UBC Okanagan Campus. I'm like a principal research chair in blockchain. I'm also co-leading blockchain at UBC, which is like a research center focusing on interdisciplinary blockchain research, right? So with this, it looks like, it's not a surprise. I also serve as a head of research for Autonomys, right? Everything looks logic. Short version. Long version, like my PhD from University of Toronto, working on completely different things. Information theory and coding theory. Yeah, and then I joined the UBC in 2015, and still at that time I worked on information theory and coding theory. And to give you a rough idea, right? Information theory is what is the best we can do, right? Assuming we have an infinite amount of resources. This is about information theory. It aims to understand fundamental limit, right? For example, what is the highest speed we can communicate between two cell phones, right? If their hardwares are bust, right? This is information theory, and coding theory is okay. Now we understand the fundamental limit, right? In reality, we have very limited resources. How can we approach the limit efficiently, right? By using a reasonable amount of resource. Okay, now with these two definitions, maybe you began to see some collection, right? With my original background and blockchain. I started my blockchain research in 2017, right? 2 years after I joined UBC because I completed a major project and I tried to find something new, something interesting. You know what? In that year, 2017, we didn't have a deep theoretical understanding about blockchain protocols. For example, right, we didn't know what is the fundamental limit, right? We didn't know how to approach it efficiently. And to me, it was like a blue ocean. Right? Wow, so many interesting and hard research problems to solve. So, right, this got me excited. I decided to jump into blockchain research immediately. Of course, some of my friends and colleagues kind of gave me a warning, right? They said, oh, wait, Dr. Feng, you're just assistant professor, right? You need tenure. Isn't this too risky, right? What if you cannot apply ideas from information theory and coding theory to blockchain? Because before, right, before 2017, almost no researchers applied ideas from my old background to blockchain research. And then I told them, well, life is short, right? We need to do something really excites us, right? Otherwise, you will regret. So under some pressure, right, I started my blockchain research almost there. And another thing excited me even more. What is the gap between research and real world product, right? Because the hint is the blockchain area is like relatively new. That's why, right? If we have good research ideas, it's like just maybe a few months, right? We can work with some blockchain company to actually implement this idea, right? This never happened in my previous research areas. So that's why, right, I had like some stories, like working with like blockchain companies, right, like turning our research ideas into real product. For the sake of time, I only share with you one story, okay, about Dapper Labs, like a flow blockchain. I'm pretty sure you have heard crypto kitties. They congested the entire Ethereum, right? I don't know, maybe back to 2018, right? And then they realized that, oh, too bad. Ethereum at that time is too slow for us. Let's build our own blockchain, right? They had wonderful expertise in NFT, right? In this like crypto, right? This kind of guns. But at that time, they didn't have real expert in the consensus. We call it blockchain consensus algorithm, right? Because we were close, and they like find out my group, right? They asked me, can you please help us? Oh, I told them, good timing. My group has been working on this for over 1 year, right? And we had like many ideas. Let's do this. Let's build a prototype, right, for the consensus algorithm. And you can turn our prototype into a real product, right? A real blockchain platform. Our collaboration was wonderful. I think within several months, my group built the prototype, let all their senior engineers, right, made our prototype into the flow blockchain. And it was a huge success. I think let all the flow was evaluated at $7.5 billion, right, for several reasons, not only for flow blockchain. So as you can imagine, right, as a professor, finally, I had some real world impact, right, in my research area. And later on, I worked with several other companies. And nowadays, right, I'm kind of concentrating with Autonomys because we want to build something even more interesting. Okay, I will stop here. Yeah, sorry for this long answer.
I love the long answer. I love the explanation. I remember when Crypto Kitties came out, and I was a advisor back then, and
Oh,
I
nice.
I was helping a they call it a patent troll company, a company with portfolio of troll not trolls, portfolio of patents. And they wanted to use a solution, and I said Crypto Kitties is perfect. I said it to the CEO, understood. I said it to their lawyer. The lawyer threw me out of the building. And I'm like, okay, you'll understand this someday. I guess today's not the day, So um, I do want to find out, what Autonomous is all about and how you're leading research efforts there to advance decentralized AI infrastructure.
Very good. Yeah, like autonomous network is building the foundational layer for AI 3.0, right? I will maybe explain AI 3.0 later, right? And it's a kind of like in our terminology, right? It is like decentralized AI, right? So simply put, at autonomous, we want to support billions of AI agents. It turns out to be not easy, right? Let me just give you a few hints. Hint number one, if you want to create an infrastructure, for billions of AI agents, your security should be extremely solid, right? Security is kind of number one in the crypto space, right? So like how to create rock solid security, right? So this is kind of one major research effort, right? The second thing is about efficiency and scalability. Why? Billions of AI agents, right? That's why we need the level of efficiency and scalability which has never been seen before, right? I have a long story about this, maybe for later, right? So this is point kind of major research effort number two, right? Number three, okay, if we want to support AI agents, we better have some framework, right? That makes the deployment very easy, right? Kind of user friendly. So this is a third research effort. So to sum up, number one is about security. Number two is about efficiency and scalability, right? The last point is about agents framework and to make it easy to use. So this is a summary of three major efforts.
Got it. Got it. So well, actually, the overall thing is the agents framework, right? So
Yeah, you
you're
can
you're
think in this way.
okay. So you're creating what's called AI 3.0, right?
Mm-hmm.
How does that differ from 2.0, first of all? And then what innovations are
Nice.
possible that we have not seen yet?
Mm-hmm. Yeah, totally. Maybe even better. Let me start from 1.0, right? 1.0 kind of traditional machine learning, right? We all know that it's like even like linear regressions, like SVM, blah blah blah. 2.0 is about this modern advanced machine learning models, such as large language models, right, based on the transformer architecture, right? This is 2.0. As you can see even from the definition, it's kind of centralized, a little bit centralized, because right, there is no emphasis on decentralization at all. Okay, this brings us to AI 3.0 because we envision a world in which AI agents act as personalized co-pilots, right? Helping us to accomplish something like bigger, right? And we know, right? Now, even nowadays, some AI agents can deliver superhuman performance, right? For a certain tasks, not all the tasks. Otherwise, we already have AGI, right? The very reason we are not there yet, just for certain tasks, right? And in the future, one thing is for sure, more and more tasks, right? AI can do better than human. So now, right, the question is like how AI agents can work in harmony. The keyword is harmony, right, with humans. And right, how AI agents can collaborate with each other. Together, right, humans AI agents will accomplish something much bigger. So this is the vision of AI 3.0. As you can see, right? Like it's not hard because the keyword, as I told you, harmony, right? There is another terminology. We call it alignment, right? Like AI alignment, very similar. So there is a company, right? Just raised billions of dollars, ASI, right? Its objective is to build the like artificial super intelligence, which is safe, right? Kind of with this alignment. So one way is to make, because nowadays I forgot to mention, no one really understands AI agents, like the internal, right? All this mathematical foundation is more or less a black box. Okay, so question number one, how to make this black box safe, right? This is the ASI company led by the previous CTO of OpenAI, Ilya, right? And we are doing something complementary. We are saying, okay, like now we have kind of these black boxes. Hopefully they are safe. But now, how can we make sure the interaction between, right, the black boxes and between humans and the black boxes kind of safe and in harmony, right? This is like some question, and we want to solve. As you can see, both questions are new, right? Never like happened before. Yeah. So this is kind of what keeps us busy.
Awesome. I'm interested to know what you said. You said you want to be able to do things that are much greater. So I'm thinking if I could find an AI agent that would help with that would actually be correct in spelling, grammar, and editing, I'd be happy. There's not one yet. There's not. I haven't found a great one yet to use. So I do it myself. But that's just on a personal level, right? You're talking about the level of humanity and society, right? So, what do you see as being possible at a much greater level of humanity and society that you're excited about?
Yeah. So like several things, right? And the number one, it's about this productivity, right? And already like it's proven for certain tasks, right? Like AI, like even not no need to use AI agents, right? Even like the current large language models, right, can kind of be more efficient. So this is right kind of so imagine if we look at the history, the so-called industrial revolution, right? Basically, if like humans' productivity can be improved, let's say at a rate of 20% for several years, right? Then it will kind of change the world. So this is like one thing, right? The second thing is I call it like very personalized, right? Imagine like an AI agent knows you very well, even like she can even anticipate your personal needs. Even before you tell her, please correct my kind of some grammar mistakes, she fixes it out. And then she tells you, hi, Jimmy, and although you didn't ask, I already did this. Is it okay? And do you want me to kind of right like revert it back? So this is to sum up. One is this productivity, right? The second is this like personalized, right? This will create a very interesting world, but everything has two sides. We shouldn't only look at the positive side, right? The negative side, as again, for the sake of time, already many science fictions pictured the negative side, right? If AI agents are way too smarter than us on almost all the tasks, right? How we should like coordinate with them, right? How to make sure like harmony, alignment, like a negative side. I don't want to go there today, right? But already some interesting ideas. Yeah.
Interesting. So I like the fact you brought up the negative side. You know, I'm not looking at negative side as far as AI right now because there's a lot. The jury's still out on what can and can't do, or how can and can't apply. But there are some major limitations when it comes to blockchain, right?
Very true.
So through your research and looking at those limitations, how is Autonomous working to solve those limitations? What's going to be possible once you solve them?
Very good question. Here, I will kind of maybe explain 5 limitations and then like briefly mention our solutions because for each limitation, I can give a lecture, right, of like 1 or 2 hours. So that's why today I just want to keep it high level and brief. Okay, the first limitation I would say is a common limitation, scalability. Like a long story short, right? We all know like Bitcoin, Ethereum, very limited in terms of TPS, right? And although we have Solana and others, right? The Sui blockchain, right? Other high performance blockchain. But if we are talking about billions of AI agents, maybe not ready yet, right? So luckily, okay, so this is a problem, right? How to create kind of this like massive scalability for billions of AI agents. You know what? My old background turned out to be useful because for current approaches, basically we call them sharding, right? The idea is let's improve the throughput by a factor of 20. If we have 20 shards, right, then maybe we create 100 shards. We can amplify the throughput by 100, right? So this is, I call it old way of thinking. And if you are familiar with the information theory, right, the right question to ask is what is the fundamental limit of the throughput, right, based on the hardware we have already. This is number one, right? After we understand the fundamental limit, then how can we approach this fundamental limit? Because if we are thinking in this way, like the previous numbers, 20, 100, they didn't matter, right? What matters is the gap to optimality. First, figure out the optimum throughput, and then tell other projects what is our gap to this optimal throughput. And if we can do this, then we can quickly figure out how many computers we need in total in order to support billions of AI agents. You see, it's a different way. It's the opposite way of thinking the problem, right? The previous way is like a multiplication, or 10 times, 100 times better, right? Our way is more like a division. This is the best. And then we divided by 1.1 because we needed to pay overhead, right? So this is, so this is, I would say, our number one research project in order to support billions of AI agents. The rest four can be explained very quickly. The second is about decentralization, right? And we know this is important. If finally we build an infrastructure for billions of AI agents, but it can be controlled by 5 entities. Still, right, not good. The hint is proof of work cannot go there. Even proof of stake, right, both from theory or like a practice perspective, right, this tends to lead to centralization because this stake, right, rich gets richer. So that's why we are based on proof of storage. And I'm not saying that it's the best choice. At least it's better than current choices. Decentralization. I can give you one hint. When it comes to computation, we have a huge hierarchy. The chips or ASIC is way more faster than CPU, right? That's why even if we combine all the CPUs in the world, still we cannot compete with the mining pools who have a lot of chips, right? Hierarchy. But when it comes to storage, such as SSD, hard disk, right? Their kind of difference is small, right? Even if some data centers have lots of storage, if we combine individuals together, we have a good chance, right, to beat major data centers. Hopefully, this hint is clear. The third thing is about trusted computation, right? And we hope that these AI agents are doing what they are supposed to compute, right? Not kind of deviate from our intention. So for this, and we leverage TEE, trusted execution environment, basically secure hardware, right? Which guarantees that, you are doing the computation you are supposed to do. This is number 3, right? Number 4, for some use cases, we have this privacy concerns, right? And we want to make it privacy preserving. The short solution is yes. On the one hand, we have multiple technologies such as TE, ZK, zero knowledge proof, FHE, fully homomorphic encryption. Right? We do have some choices, but the thing is, each of them has its own issues. What we are doing here, right, is to do some smart combination so that we can propose a solution like leverage, right, the advances of multiple projects. Yeah, and we have some ongoing research papers. Finally, if we want to support billions of AI agents, we need to have enough block space or on-chain storage, right? And currently, on-chain storage is expensive. If we want to store 1 gigabyte of data, only 1 gigabyte, right, on Ethereum, you do the quick calculation, over $2 billion, 2 billion, right? For Solana, 1 gigabyte of data, maybe $500,000. And we can say this is not good, right? And we really need to bring down the cost from $500,000 to maybe $10. If we can do this, right, then we have a hope to support billions of AI agents. You see, right? I quickly outlined 5 issues and with some kind of hints towards the solution. Oh, I forgot the hint for the last one, right? How can we bring down the cost so significantly, right? The hint is we are based on proof of storage, right? So that's why from first principles, we are relying on storage and to build the entire blockchain. We have the direct control over storage compared to proof of stake, right? That's why from first principles, because we have direct control and we can make the most efficient use of storage so that the cost can be very low.
Wow, you're working on a lot. That's great. Yeah, it sounds, and I could see in your answers how when you first talked in the beginning, you said coding theory, and I didn't know I didn't really understand what that was, but now after you explain all that, I clearly see all of it includes coding theory and informational theory. So that's great. I was going to find out, how AI could be more accessible, but that might be another rabbit hole. But I think I want to ask about this proof of storage, right? Because a lot of people say that Bitcoin is not accessible. Bitcoin is too slow. Bitcoin can't be used anymore for transactions. But how would things work if you use proof of storage instead of what do they use today? I don't know what they use today, Lightning, to help the proof of work networks become more accessible and become faster and more scalable and transparent, and how can proof of storage supplement this proof of work?
Yeah, I would say, yeah. So number one, right, this is a wonderful technical question, right? And I just want, so just to echo your point, and people blame that, it's energy hungry, right? Because of this massive computation. Yes, and the reason now is clear because the entire security is based on computation. Computation consumes energy, right? And that's the reason, like we have all these downsides you just mentioned, right? How can we address this issue? How can we address this issue? The question should be from like first principles. Why we have to best, right? This is why we have to like put the security, right? Based on this computation. What if our security is based on storage, right? That is completely a different world. If your security is based on storage, all of a sudden you don't need to do this massive computation at all, right? The only computation you need to do is to kind of show that, oh, I have enough storage, right? If you don't trust me, ask me to compute something, right? Even if only when I have all the data, I can compute this function. So my computation, right, can be very quick, and just the computation is used to convince you I indeed have the data. You see, this is a completely like a paradigm shift, right? From like computation resource to storage resource, right? After this shift, here comes the shift itself is not hard, right? And there could be a new project like doing proof of storage. The hard part is this shift will not compromise any security compared to proof of work, because right, fundamentally storage is different from computation. Let me just highlight one difference, then you will see why, right? For the computation, if you didn't use any computation in the past hour, then it's kind of a waste. You cannot go back in time, right? Because we didn't have time machines yet. For storage, right? And you can like you could do this. You didn't use the storage for the past hour, and later on you realize, oh, maybe in the past hour, like some like the honest storage is limited, then you can pretend to go back. In other words, right, in proof of storage, like it is possible to have a time machine to go back in time, right? This is too bad. And that's why, right, we build another protocol called proof of time. Roughly speaking, with proof of time, no one can go back in time. We get rid of time machines so that, right, we don't lose security. This is just one of many things we did. Now you see the entire picture, right? Although the basic idea is so easy, don't use computation resource, use storage resource instead. But, right, this shift opens so many attack surfaces. And we need to do smart things to close each and every surface. And that is like, this gives you a taste of proof of storage blockchain design. That's why, right, we have several researchers, like very like smart people, Shashank, Barak, like we are trying our best to close every door.
Yeah, that's you know, it doesn't sound technically difficult, but the difficulty is going to be in the with a shift. It's going to be the paradigm shift. You
Yes.
know, yes, that's the harder part, and old paradigms die hard. So so I want to I have one last two questions. Actually,
Mhm.
one last question. I'll put it together in one. I want to thank you very much for your time today, and I'm hoping to bring you back in maybe September, October timeframe during my next season to talk about this proof of time machine. I think that would be like a very great conversation.
Yeah.
I want to find out, how can people find out more information about you and about Autonomous, but I also want to find out the state of your upcoming TGE launch and other advancements in your pipeline as well.
Okay, cool. So number one, right? Check our website, and maybe I will share with you the link later, right? And then number two, we are so welcome to for developers and researchers, right? As you can see from our conversation today, it's ongoing, right? And we still have some exciting research directions to explore. And to me, right, for the benefit of the entire humanity, it should be a collaborative effort, right? It's not just about one company, one project. We really hope more researchers and more developers, right, could join us so that we can build something together. Right? One project cannot solve all the problems, right, for the decentralized AI and for the future of these agents, humans in harmony, right? Definitely. And we need, right, this kind of community effort. To me, this is the best way leading to innovations. If we have some platform which facilitates this open innovation, right? And by the way, blockchain is a good platform. Why? It has the so-called fair compensation. Think in this way. If you kind of fine-tuned some open source model and deploy your model or agent on a blockchain platform, right? And then all these usages can be tracked so that you can be rewarded based on how many people are using you, right? And what kind of are your contributions? So this is no longer a black box. So that's why, right? Decentralized AI, to me, the beauty is open innovation. Now, back to the second part of your question, right? Kind of what is our current state? As you already say, we are very scientific and serious, right? Because this security, everything. So we apply the same style to our TGE. I just want to mention two things, right? Number one, we partnered with Token Soft to make sure, right, our TGE is fair and compliant, right? And we don't want to sacrifice anything. We want to make it fair and compliant. So almost done, right? This is number one. And number two, previously we planned to launch our mainnet phase 2 in Q1, which means end of March, right? Why we didn't? Because this rocket solid security, right? Roughly speaking, after we have our design, we need some auditing company to do this deep checking, testing. So right now we are waiting for our auditing results. But the good news is all this is open source in our GitHub. Right, everyone can verify. Oh, what is the current status of auditing? Right, how many issues are still pending? Right, how many are finished? And people can see the progress in real time. Again, this is the beauty of Web3. So transparent, and everyone can check, everyone can verify. Yeah. So to sum up, right, our TGE from with token soft should be compliant, right, kind of fair, everything. From the legal side should be very solid. Then on the technical side, we need this auditing. The entire progress is completely transparent. Once the auditing is finished, maybe we will do the last we call it a stress test, right? We need to simulate the worst case scenario. Then the first two will be launched. Yeah. So now I guess like you can see, right, the kind of picture of where we are. Thanks
Awesome.
again for having me. Yeah, it's quite a pleasure to chat with you.
Awesome. Thank you very, very much for your time today.
Yeah, so welcome. Yeah, have a wonderful day. Talk to you next time.